AutoCAD Electrical. Although it's called AutoCAD Electrical in theory should be called AutoCAD Controls, as it has a comprehensive pneumatics, hydraulics and P&ID library included. Moreover, with the CAD line localizer, it includes a pneumatic metric to ISO 1219, a hydraulic metric library in accordance with ISO 1219, and a P&ID library in accordance with ISA S5.1. The principles of drawing any control diagram are exactly the same, whether it be electrical, pneumatic, hydraulic, flow processes, or indeed P&ID drawings. Let's take a look at a P&ID drawing. Even line styles can be defined to depict, for example, pneumatic circuits or instrumentation circuits. Take a look at a simple pneumatic drawing. The principles are the same. Going to a more complex hydraulic drawing, you can see that even when flow processes go from one page to another, you can very simply navigate from that page to the destination. And AutoCAD Electrical will automatically take you there and zoom into the location. With the CAD line localizer, specific commands simplify the functionality of pneumatics, hydraulics and P&ID. Simply pressing Insert Pneumatics only brings up the pneumatic menu, but of course in the metric version in accordance with ISO 1219. Likewise for hydraulics, and similarly for the P&ID components. Components are logically grouped. So if I select equipment, I only get icons with regards to equipment. I can also select from the list down the left hand side, and similarly I get just my pumps in this instance. Pipe types can be defined. And basically they're based on layer names with additional information. Let's activate the P&ID project and we'll open up a blank drawing and draw a simple P&ID circuit. Symbol size is user definable, of course, and we can enter a description as to what the tank is doing. Even if we use a mixture of uppercase and lowercase, AutoCAD Electrical automatically rectifies that for me. I can also assign manufacturer and part number at this stage and define its location, effectively its sub-assembly information. We could also use the duty information here on line 3. When inserting components, I do have a choice of scale factors. So I can choose what size tank I actually want to place, and you can see it automatically goes up to the next available component tag. Of course, this can be fixed and can be forced, and the information can also be pulled from an Excel spreadsheet or a CSV or a text file. When a component is deleted, it's deleted out of the item. And of course, if we wish, we can reset and renumber components as well. When drawing pipes or flow processes, we can see the connections of a component And even if we're rough with our drawing, as to where the connection points are, AutoCAD Electrical will automatically cut back to the actual device. We might wish to have some fittings, a flange maybe, but we've decided the flange size is too big. So we can always change the attribute and the scale factoring of the flange so that when we insert it, it inserts at a better size. If I repeat the process and place another flange here, you'll see it automatically cuts back the pipe as well. Right click repeats the command, and we might wish to have a field mounted device being placed here. If I type the component tag in, let's say it's LG1015, you'll note that it automatically splits the component tag. I can right click over a pipe and use the change convert wire type command using the marking menu, and if I wish I could actually change this over to a different pipe type. Alternatively, I can actually change pipe types by using the commands from the drop downs. I want a connection going across here. Again, I can be quite rough about it. And we want to go maybe down to about here and across and place this here. Insert another device. We'll maybe have a pump, centrifugal pump. And again, you'll notice it's automatically cut back the pipe or the flow. Again, inserting some pipe. If I specify what I want to connect from there, you'll notice that it will automatically cut back the pipe to the relevant point. And we might wish to insert another tank, but with a different scale factor on this one, round about here. Directional arrows can be added. And placed on our circuit to indicate the direction of flow. Add in some more fittings. This time a different scale factor. And we might wish another flange to be placed here. And as you can see, it automatically indexes up to the next available number. and cuts back the pipe in accordance. We might wish to have a valve, maybe a diaphragm valve, and again I can place that down and it numbers automatically. I've got a choice. I can actually type in the value here, and give it a description. Or indeed I can place down identifiers to signify that this is the valve, in much the same process. Any component we can assign a manufacturer and part to. As a default, AutoCAD Electrical's parts database is predominantly electrical, pneumatic and hydraulic. But we can create new components in the parts database with manufacturer part detail. And this will be information that will fill out into the reports. So as an example, this might be an isolation valve. And it might have a certain manufacturer. Let's say the manufacturer is CAD line and the part number is XYZ123. And this may be a detail about the product, so this might be the actual maximum operating pressure, the features, it might be a single piece. Well, in actual fact we'll actually enter some relevant information such as the manufacturer's Spirax, and the part number is M21 SK3 as an example. And we could enter query information about the product, so this is 316L, this might be the material of course, and further information about the product as well, well it's a ball valve, and this is all information that can be shown in the reports. In fact, you can write an essay about the product and also link it to the manufacturer's PDF or installation document to automatically produce a set of PDFs which relate to your OEM manuals. Once you're happy with filling in the information, as I said, you can write an essay about this, and this is all information that will appear in the bill of materials. I can say OK and OK. And we can do that process on any type of component. Now this component, if we just edit the component, you'll see automatically has a WD type of PI for P&ID. That basically means when we produce a report, we can decide whether we want a bill of materials based on schematic, hydraulic, pneumatic or P&ID, and I'll just do the report just for a bill of materials on the active drawing. We can do it in a tallied purchase list format, which will give us a quantified list of items, or indeed we can do the bill of materials by tag. Which will give us our component tag and where it's located, and of course the description, the manufacturer, catalogue and quantity. Any of the reports are customizable. Simply by selecting change report format, we can alter what information is shown. And this may be that we need to include the query 2, the query 3 and the miscellaneous information, etc. So going back to when we created the part, if we did write an essay about the product, it will all appear within the report. Even the headers can be changed. So instead of maybe query 3, we might wish to have the word type or valve type. And that's the information that will then appear within the report. So you can very quickly create a schedule of all your devices with your component tags, maybe even the client's component tag, the assembly or subassembly information, description of the component, where it's located, and of course the rest of the technical data about the product. Additional reports as well, we can actually produce a component list. This is useful if we need to tag all the components up using a marking system. And those are all the components that we've used in the set of schematics so far. We can decide how that information is shown by the properties of the project. So instead of the installation or subassembly being shown within the reports, you'll see now if I produce a report based on the P&ID that only the primary tag is actually shown. In addition, using the import-export data, we can export this data, whether it be the components, the parents only, or whether it be the pipe numbers and layers, or even the drawing settings. We can export this information to spreadsheet. We'll just save this to our desktop. Opening up the P&ID Excel spreadsheet, you can see all of the information about the product, and we can start to fill in information within here. So it could be that we know who the manufacturer of the pump is, and by typing in a manufacturer and a product number, obviously it should be a valid part number, but we can, by altering the component tags in here, and we might decide that the component tag for this device for maybe the gate valve should be MV5305 as an example. We can then update the schematics with this relevant information. So as you can see, this device has automatically been changed to MV5305, and of course the pump that we decided we were going to edit to assign a manufacturer of gold has automatically been annotated as well, thus meaning when we go back to reports, very quickly and easily for our P&ID, specifically thinking about the gold pump, you'll see that the gold pump now is in our bill of materials within AutoCAD Electrical. Therefore, to reiterate, AutoCAD Electrical is not just for electrical drawings, it can be used for pneumatic, hydraulic, P&ID and indeed any flow process requirement. Any information that we output to Excel, we can update the Excel document and import it back into the drawings. We can get lists of components, lists of the connections between the components, bill of materials by tag, schedules of our equipment, etc. And using the localizer, the CAD line localizer, we get additional functionality. We get metric, pneumatics, hydraulics, P&ID, symbol libraries, in accordance with the relevant standards, and unique commands which simplifies the operation of using AutoCAD Electrical for these disciplines.